Section 7.3, simplifying complex rational expressions. So what does it mean to be complex rational expression? Well, a complex rational expression is when you have fractions over fractions. So like I said, Chapter 7 is all about fractions. So if you were having some difficulty understanding fractions, well, Chapter 7 concepts, hopefully, and spend lots of time on Chapter 7. Do not try and cram it in all in a couple of days. You definitely need to spread this chapter out. So Method 1 and Method 2 are some things I would write on a note card. And I tried to give you some reasons why I'd use Method 1 and why I would use Method 2. You can always use Method 1 by changing Method 2 into Method 1, but I kind of like to keep them separate. So Method 1 is if you have one fraction over just one fraction. So you got to make sure you can spot that out. And if you have just one fraction over one fraction, that really is just changing division to multiplication, flipping your second fraction, that means the one in the denominator, and then using the multiplication rules. So we've already done that in section 7.1. Method 2 is if you have multiple fractions over multiple fractions. And if you do the LCD and multiply the whole numerator, taking the whole numerator and the whole denominator and multiplying by the LCD for all the fractions. When you do that, you should have a nice fraction left. Combine like terms, factor if possible, and then cancel any like factors that appear on top and bottom. So if you want to do Method 1 and Method 2, we first have to be able to pick out, do we have one fraction over one fraction or multiple fractions over multiple fractions? So on number 1, this would be Method 1 because you have one fraction. We're going to use Method 2 because you have multiple fractions over multiple fractions. So on the first one, Method 1, what does it say to do? Change division to multiplication and flip the second fraction. So 5 over 9, change division to multiplication and flip the second fraction, so 12 over 7. And then just use multiplication rules. Because we have no addition signs or subtraction signs, we can just multiply straight across. So 5 times 12 is 60, and 9 times 7 is 63. Then we look to see if we can reduce, and there is a 3 in common, so we can say our final answer is 20 over 21. Now Method 2 says if you have multiple fractions over multiple fractions, we want to find the LCD for all fractions and multiply the whole numerator by it and the whole denominator by it. So we're going to have to find the LCD for all fractions. Well, what are my denominators? I have a 6, a 3, a 4, and an 8. So I want to know what is my LCD. Well, 6 is 2 times 3. 3 is just 3. 4 is 2 times 2. And 8 is 2 times 2 times 2, making sure you go all the way down to primes. So how many 2's do I need to take? I need to take all 3 2's because there's 3 2's here. That'll take care of those 2. That'll take care of that 2. And I need 1 3 because I had a 3 here and a 3 here, so I need 1 3. So what is 2 times 2 times 2 times 3? That gives me 24. So my LCD is going to be 24. So I need to multiply the whole numerator by 24 over the whole denominator by 24. And look what you're really doing. 24 divided by 24 is 1. You're just multiplying by a unique kind of 1. So I'm going to put this over 1 because it's easier to see when I multiply. So when I multiply 24 times 1 and 1 times 6, I get 24 over 6. When I multiply 24 times 1, I get 24, and 1 times 3 is 3. And the denominator, 24 times 1 is 24, and 1 times 4 is 4. And 24 times 1 is 24, and 1 times 8 is 8. Now that does not look nice at all, but you can reduce. 24 divided by 6 is 4. 24 divided by 3 is 8. 24 divided by 4 is 6. And 24 divided by 8 is 3. So knowing your multiplication well is going to be very helpful. So if you're not so keen on your multiplication, please start doing some memorization of your multiplications. 4 minus 8 is negative 4, and 6 minus 3 is 3. So my answer is negative 4 thirds. So those are the different methods. If you have one fraction over one fraction, or if you have multiple fractions. So let's try some other problems. So for number 3, you actually have multiple fractions over multiple fractions, so I'm going to use method 2. This one, you actually have just one fraction over one fraction, so I'm going to use method 1. I know you see a plus sign or minus sign, but it's still just one fraction over one fraction. So going back to number 3, we need to find the LCD. We have an x, a y, an x, and a y. So hopefully you see that your LCD is just xy. So what do? We multiply the whole numerator by xy and the whole denominator by xy. And again, I'm just multiplying by an interesting kind of 1, because xy divided by xy is just 1. I'm going to show the step one more time, and then I won't show it as much. Xy times 1 is xy, and 1 times x is x. Xy times 2 is 2xy, over 1 times y is y. And the denominator, xy times 2 is 2xy, still all over x. And xy times 1 is xy, and 1 times y is y. So I'm going to cancel out what cancels. Y is left. Y is canceled, so 2x is left. Here, x is canceled, so 2y is left. Y is canceled, so an x is left. Then I do try and factor, and nothing can be factored because the only thing we could look for is a GCF. There's no GCF in the numerator nor the denominator, so I am done. All right, on number 4, we have one fraction over one fraction. So we have 2x over 3x cubed minus 3x. Change division to multiplication and flip the second fraction. So this fraction gets flipped. Then what do we try and do? Well, because we have all multiplication, we can just factor. The 2x will stay as 2x. 3x cubed minus 3x. We're going to look for GCF first. And the GCF would be a 3x. And we're left with x squared minus 1. In the other numerator, we see there's a 6 in common. So I'm going to take out a 6 and I'm left with x minus 1. And we just have a 4x left in the denominator. Now hopefully you see x squared minus 1 can still be factored. So we still have the 2x. Draw my line. We still have the 3x, but x squared minus 1 factors into x plus 1, x minus 1. And we'll still have the 6 times the x minus 1, and we'll still have the 4x. So what cancels? Well, we have an x minus 1 on top and bottom. This x and this x can cancel because there's no adding or subtracting. It sticks those things together, so those can cancel. We can multiply our numbers together, or if you want to cancel, you can. I'm going to get multiplying my numbers together. 2 times 6 is 12, all over. In the denominator, 3 times 4x is 12x, and I'm still left with x plus 1. So still looking to see what can cancel. I see there's a 12 on top and a 12 on bottom. Again, we have all multiplication, so we can cancel. So my final answer is 1 over x times x plus 1. If you want to distribute in the x, you can, or leave it as is. So on number 5, we're going to list that as method 1 because you have one fraction over one fraction. So change division to multiplication and flip your second fraction. And if you get, I'm going to give you the answer, but I want you to try to get to the answer of 4/3. So the answer to number 5 is just 4/3. All right, number 6 is method 2 because you have multiple fractions over multiple fractions. So we need to find the LCD. Well, what are my denominators? Well, that's just a 1, that's just a 1. So I have a 1, I have an x squared, and I have an x. Squared is really x times x. So my LCD is going to be the x squared. So I'm going to multiply the whole numerator by x squared. Again, that's over 1. And the whole denominator by x squared over 1. I'm going to skip showing this step in between. I'm going to go ahead and just cancel out what cancels. So when I distribute 4x, so x squared times 4, 1, but divided by x squared, you're just going to get left with a 1 once you reduce. X squared times 4 is 4x squared. X squared times 4, but divided by x is just 4x. And x squared times 1 over x squared just gives me a plus 1. If you have to show this step in between, feel free to do so. I'm just getting to the point where I've already canceled stuff out. So now at this point, I do try and factor. Looking at the numerator, this is a difference of squares, so this factors into 2x plus 1 and 2x minus 1. And the denominator, this is your AC method, but it's also perfect squares, and this would factor into 2x plus 1 and 2x plus 1. So then I cancel any like factors that appear on top and bottom, which is a 2x plus 1. So I'm left with a 2x minus 1 over 2x plus 1. So on number 7, we're also going to do method 2 again, because it's multiple fractions over multiple fractions. So this is method 2. How do I start off? By finding my LCD. So I have an x, and this is a 1, and this is a 1, and I have an x cubed. So really I just have an x and an x cubed that I have to deal with. Well, x cubed is x times x times x, so I know my LCD is going to be x cubed. So I'll multiply the whole numerator by an x cubed, again over 1, whole denominator by x cubed over 1. So x cubed times 1, but divided by x is just x squared. Again, if you need to show the step in between, go right ahead. I'm going to go ahead and just cancel as I go. X cubed times 2 is minus 2x cubed. And the denominator, x squared times 1 over x squared is just 1. And x cubed times 8 is 8x cubed. So then now what I need to do, I try and factor. So in the numerator, it looks like a GCF is in common between an x squared, and I'm left with 1 minus 2x. In the denominator, this is a difference of cubes, so follow the difference of cubes formula. So it's going to be 1 minus 2x. Take 1 and square it. Take 1 times 2x, which is 2x, and then take 2x and square it, which would give you 4x squared. So I'm just doing that formula from chapter 6. Hopefully you're comfortable with the cubes formula. Cancel any like factor that it appears on top and bottom. So I'm left with an x squared on top, 1 plus 2x plus 4x squared on bottom. And lastly, we have t plus 9 over t minus 7 all over 11 minus 3 over t minus 7. This is method 2. Multiple fractions over multiple fractions. So what's the first thing you have to do? Find the LCD. So am I looking at this problem? My only LCD is t minus 7 because the other denominators are just 1. So I'm going to multiply the whole numerator by t minus 7, whole denominator by t minus 7. Again, these are over 1, so then I can cancel as I go. So when I distribute t minus 7 times 2, I get t times t minus 7. Plus t minus 7 times 9, but divided by t minus 7, I'm just left with the 9. In the denominator, I'm going to have the 11 times the t minus 7, minus the t minus 7's cancel, and I'm left with the 3. So I'll distribute my t. T times t is t squared. T times 7 is a minus 7t plus 9. All over 11 times t is 11t. 11 times 7 is 77 minus 3. So then I end up with a t squared minus 7t plus 9 on top over 11t minus 77 minus 3 would give me a negative 80, so minus 80. I do try and factor, but there are no factors of 9 that up to negative 7, so the AC method is out, and there's nothing I can do with the denominator. So my answer should be t squared minus 7t plus 9 all over 11t minus 80.